A new plugin has been developed that allows us to analyze the machine tool simulation so that we can interrogate the linear and rotary axis movements within a toolpath for any potential issues such as axis reversals, for example. If we view our plugin window, here we can see the simulation analysis plugin at the top, and we'll just go through an example of how to use the plugin. So if we simulate from start, activate the toolpath and then simulate from start, and then save the simulation, you can see a line graph is produced for each individual axis. If we click on the small view here, then it brings up a much larger window. So each individual axis is drawn in a separate colour, and we can plot the axis angle against the time or against the number of points in the toolpath. So if we look at time based, we can see here that most of the axes are well behaved, with the exception of the blue line here, which is the C axis. So the C axis is the rotary table on the machine. So if we just fast forward the simulation to the point where we get these large dips and large peaks in the C axis. So you can see the C axis is rotating positively, and then all of a sudden it reaches this peak of around about 82 degrees, and over the time period of what is literally 1 second, we have a full almost 180 degree swing of the C axis from positive 82 degrees to negative 87 degrees. This all occurs over a very small distance, over a very small period in time. The reason for this is because of the design of the part, where the draft surface on the side of the part goes from positive to negative. And because of this positive to negative shift in the draft, the machine tool has no choice but to swing through 180 degrees with very little movement across the surface of the part. So this is going to lead to a very potentially a very bad surface finish in this part, because we have a very rapid movement of the C-axis but a very small movement along the part surface. So this is obviously easily identifiable using this new simulation analysis graph. So let's have a go at getting rid of this sudden swing in the C-axis. Now the only way to achieve that would be either to remodel the part, which obviously is not possible in a lot of cases, or to reorientate the part on the table so it doesn't go from this positive to negative draft angle. And the way we can do that is by simply using a different datum orientation and to position the part on a angled vise, like so. So now if we rewind the simulation and replay the simulation and then save the simulation again, and then view the analysis, we can see now that the C axis is far more controlled and has none of the peaks and troughs that we had in the previous toolpath. So if we now just play the simulation again forward, we can see at the point where we had the sudden swing in the c-axis, it is now nice and controlled and there's very little or no movement in the c-axis. The only time the c-axis now is rotating a large amount is when the tool has to swing around the front, but again it's in a controlled manner. And back to the beginning. So the simulation analysis graph is a great visual tool for easily identifying any potential problems with our toolpath in terms of possible surface finish issues or axis reversals.